Well, welcome to the ATP Project. You're with your host Matt today over in Vegas with my good mate Rich Kreider. So today we're going to talk about, I don't really know. We'll make it up as we go. But we're at the ISSN conference in Vegas, the 2019, and it has been absolutely amazing. So Rich, for starters, we better explain what ISSN is.
Sure.
Yeah.
The ISSN stands for the International Society of Sport Nutrition.
Yeah.
And this is a group that started in 2003 or so.
Yeah.
And the founders are myself, Doug Kalman, Joey Antonio, Anthony Almada,
Yep.
and also Susan Kleiner. And it started being at a conference. We're actually at the American Dietetics Association conference in Chicago, all speaking. And we looked at each other as like, well, we're the experts. And we always had to go to the American College of Sports Medicine meetings and American Dietetics Association to talk about sport nutrition, but it was always a small segment of the conference.
Yeah.
And Sue Kleiner was across the table and says, well, why don't we just, we're out to dinner, why don't we just start our own?
Yeah.
And I had worked with the American Society of Exercise Physiology a few years before and helping form that with Tommy Boone. And that's what we did. So we contacted Human Kinetics, who became one of our sponsors. We officially formed it. Rick Collins is one of the attorneys that's been with us forever, and he's done a lot of writing and muscle and fitness and things. And he became our legal executor, and we started forming all the content. And so we've initially sponsored with Human Kinetics and the International Journal of Sports Nutrition and Exercise Metabolism, which I was one of the associate editors for. It became the official journal of the ISSN. A few years later, we decided to do our own, so we contacted Biomedical Central, which is Nature Springer, really high quality. And so they've been our journal publisher since 2007 or so.
Yeah, right.
And so
is it peer reviewed?
Absolutely. Yeah.
And who's reviewing it? Is it?
So I was the initial editor in chief, and now Joey Antonio and Doug Kalman are co-editor in chief.
Excellent.
And so the articles come in, and we review original research, but we wanted the International Society of Sport Nutrition to be a leader in the field, helping practitioners and scientists make informed decisions about the science of supplementation and performance enhancement through nutrition. So we've done a lot of position stands on everything from the Sport Nutrition Review, which was the launch of the journal, which has been that one article has been downloaded almost 1.1 million times.
Yeah, wow.
And then we have position stands on creatine and protein and meal timing and HMB and beta-alanine and a number of things. And so they have been really the foundation for the practitioner, the athlete, the coach, and even the scientist of what is the literature and how can you make informed decisions about what nutrition is for optimizing performance.
And what is sports nutrition? I mean, are we talking macros? Are we talking micros? Or?
We're talking all of it.
Yeah.
So it's the combination of proper training, proper base diet, and then how to manipulate the diet and strategically to optimize training adaptations, optimize acute performance, both from a physical as well as cognitive, and then the overall health of an individual.
Now, it's pretty early in this conference, but so far I've seen, we've talked about gut health, we've talked about sleep, we talked about different forms of exercise training and muscle hypertrophy and what it actually is changing, so we can work out what to drive. Or we talk about responders and non-responders and that sort of stuff. It's actually a lot more than what I thought it would be. It was just talking about, branched chain amino acids or something like that. So one thing you mentioned before with position statements, such things as creatine have had an amazing amount of research, a lot of really cool data, but I heard it was a steroid. No, with creatine it was crazy because I've never heard such criticism about a supplement as creatine, but if you actually have a look through these position statements and look through the data, it's probably one of the most well-researched of all. It
is. And we heard a great talk from Eric Russin yesterday looking at history. Yeah. And he talked about in the 1800s, they actually started doing creatine supplementation and meat, right? Yeah. And then in the early 20s, there were a number of studies. Actually, the first ones I saw were in 1908 and where they were giving animals creatine, and they noticed they increased their body weight when they gave them creatine.
Yeah, yeah.
And then they started, they had a number of studies and identified the role of creatine in ATP and phosphorylate and energy systems in the 20s.
Yeah.
But before that, they had made these observations that if you gave creatine, the body restored it. If you gave creatine, you gained more weight.
Yeah.
And so that was kind of the beginning.
And it really holds it. Like, it's not just filling it with salt, is it? Like,
Absolutely.
you load up on you can load up on creatine, and that will hold that water. But it takes about, Eric was saying yesterday, you stop, and about a month later, it's actually depleting. It takes about a month to deplete.
Yeah, so you can kind of think of your creatine stores like a gas tank that on the normal capacity is about 2/3, maybe 3/4 full.
Yeah.
And so the body gets creatine from the diet, from meats and fishes and different type of red meats primarily. And when you consume 12 ounces of beef, for example, you'll get about 2 grams of creatine. So it's readily in the diet.
Yeah,
and
yeah.
One of the things that Eric showed is, some of the initial sport nutrition efforts for people, hundreds and thousands of years ago, legends of strength and feats and in Greece, they all had high protein diets.
Oh, and how much protein? There was
20 pounds a day.
20 pounds a day. 10 kilos of meat.
Well, when I was playing football, it was 2 steaks a day.
Yeah, yeah.
And there was no creatine. We didn't know much about that and that type of thing. And it was protein and lots of meat. And so I think the athlete knew.
Yeah.
And so really we were all creatine loading.
Is that what got you into it? Is that what got you looking for it?
Yeah, football,
The steak and...
Yeah, so it's like, how do we optimize? And I was always a little smaller than others, so I had to really train hard to keep muscle mass up to be able to be competitive. And, especially in American football, they're so big, So that was my interest, strength conditioning.
Yep.
Wanted to be a strength coach, and then I started getting into nutritional aspects of performance. Early in my career, I worked with Mel Williams, who was really, many people think of as the father of sport nutrition.
Yeah.
Great book in the late 70s, early 80s on ergogenic aids and things. And so I worked with him the first few years of my career, and we did a number of studies, and creatine was one of the things we started looking at. Yeah. But creatine is one of these things that you need in your diet. It's essential for the body. You get it from the diet, and what you don't get in the diet, your body actually can synthesize in tissues like kidney and even in the brain.
Yeah, yeah.
So your body.
So I was going to ask about the plant-based diets. Are they getting any creatine?
Well, not as much, and so that's the concern. If you're a vegetarian, we know that your muscle creatine stores are much less. So the idea is it's almost like carbohydrate loading. You add extra carbohydrate diet, you store more glycogen, muscle glycogen, and you can perform longer. Well, for sprint-type exercises, creatine is the primary fuel for the high-energy sprinting.
Yeah.
The 1 second, 5 second, 30-second sprint bouts. And so by loading creatine, adding more creatine in the diet, you can actually fill that tank up.
Yep.
And then you have more energy for explosive activity and recovery.
So you'd be thinking, I'd be thinking if I was an endurance athlete, I wouldn't need creatine then. But I know I've watched endurance. I've never competed. I've watched lots of endurance, but you'll see the cyclists. They got little moments of sprints. So even in those sort of endurance sports, you'll hold that creatine and use that for the short power.
Yeah. So when creatine came out in the U.S., actually the history was in England for the '92 Olympics. Some of the sprinters. Christie from Great Britain, who won the 100 or so.
Yep.
They all were talking about they were using creatine.
Yeah.
And I actually was in Soviet Union, and when after the curtain fell, and a meeting in '94, and they had a whole history of creatine use in their athletes for years and years, and knowing exactly how much creatine was in the diet to be able to titrate. Now they may have been doing other things as well, but certainly creatine was known for athletes at least. And so in the late 80s, early 90s, it kind of became in vogue because it became available as a supplement. And then Eric Holtman, who's a person who was really instrumental in developing the muscle biopsy technique, and Roger Harris in England did some studies with Paul Greenhoff at University of Nottingham to show that if you gave creatine, it increased the muscle content, increased blood concentrations, you stored more, and you were able to do a little bit more muscle work, knee extensions and things like that. So we did in '93 or '4. I got contacted by Anthony Almato.
And in Australia, we would know him mainly through Vitago, is
Yes,
it?
yes.
The carbs? Yeah.
That's the same Anthony. So they had started a new company called Experimental and Applied Sciences, EAS, which
Yep,
became
that's right,
a
yep.
multi-million-dollar company.
Yeah.
And their first branded thing was creatine.
Yeah, okay.
And so we did some initial studies. The first studies in athletes were basically done in our lab at the University of Memphis.
Yeah, okay.
And we found that if you added creatine to carbohydrate, you gave it to, in our case, American football player type heavy resistance trained athletes, they increased muscle mass by an extra 1 to 2 kilos compared
Yeah.
to controls
Yeah.
over a 4-week period. It worked as fast as 14 days, would start increasing muscle mass, and take it for a month, you're going to increase your strength, your
Yeah.
power. So then we added it to protein powders,
Yeah.
and found huge benefits when you add it to carbohydrate and protein kind of energy
Yeah,
drink
yeah,
or
yeah.
a protein powder.
But it needs those carbs. It needs those carbs to drive it in.
Well, it helps. So
Yeah.
we know that if you co-ingest creatine with carbohydrate, you can increase the muscle concentration. But it's more than just energy.
Yeah.
There's so much more creatine's involved, we now know.
Yeah.
So getting back to the point about endurance athletes, we used to think it was just for muscle heads, for just
Yeah.
guys that are slapping iron around the gym.
Yeah.
It's not.
No.
We now give creatine for endurance athletes for several reasons. One, if you take creatine or have your muscle high in creatine and you are carbohydrate loading for a big marathon or a race or a triathlon, you store more carbohydrate in the muscle.
Yeah.
So if glycogen loading is important for performance, which endurance athletes, then it can help you.
Yeah.
We now know that after endurance exercise, it helps reduce the amount of damage the muscle is associated with, so you can recover better.
Yep.
Endurance athletes like cyclists and triathletes often lose a lot of weight during their season, 5-10 pounds, mostly muscle with
Yeah.
a lot of fat, and it can help preserve that muscle mass to keep your power output during a long season better.
And even water. I mean, does it maintain hydration status
Well,
better as well? I mean, because
yeah.
is that water used up already? Is it the same water?
Yeah, so one of the initial things we heard about creatine is it caused cramping and dehydration, which
Yeah.
all the studies actually show completely the opposite.
Because it holds water. I mean, how could that dehydrate you?
Yeah, so that's the irony of it.
Yeah.
So when you have creatine, it's creatine monohydrate is the main form. So you tend to have a little bit of extra fluid in the cell
Yep.
that stimulates protein synthesis, which is great for muscle rebuilding, but also hydration.
Yeah.
And so they've done studies where they've had creatine, and it helps maintain a better temperature during exercise. It helps you maintain your fluid better balance,
Yep.
so you don't dehydrate as easily. If you add it with things like glycerol, which
Yep.
also causes hyperhydration, you get a greater effect. And so for endurance athletes, it can be
Yeah.
a way to help them sustain high-intensity exercise and not
Yeah.
be dehydrated.
And even for the everyday athlete and weekend warrior, really, having all those benefits, you're going to train harder. You're going to feel better, so you're going to put in a little bit more effort and get better results for your
and
efforts in
some
the gym anyway.
initial studies that were done with Bill Kramer and Jeff Olick kind of showed that if you take it for 12 weeks, not only do you get more muscle mass and your lean mass from body composition tests go up, they were able to show that muscle fiber diameter goes up. So it's
Yeah.
actual hypertrophy. It's not water.
Yeah.
All of our studies never showed a water effect disproportionate to your body mass. So if you gain
Yeah.
10 pounds, 70% of muscle's water, so you're going to have some water retention.
Yeah.
But it's not out of proportion. And so those studies showed that your people who were on creatine were able to maintain higher workloads during training.
Yeah.
And so they were able to tolerate training. They did more because they felt better, and that ended up leading to the greater training adaptations.
The other sport I thought, because I know we're also looking at creatine now as something that might be good for the brain and concussion. And I do a little bit of work with some fighters, and I thought, it might be a really good opportunity with fighters. But then they can. What about weight? I'm always conscious because a lot of my guys are really pushing their parcel, because you can't just deplete. Like if it was carbs and salt and sugars, I could deplete those, and the water will go and the weight will go. But you can't do that with creatine, can you? You don't drop weight.
You have to be smart. So you wouldn't load before a weigh-in or something like that.
Yeah.
But if you had been taking creatine chronically and only are taking 3 to 5 grams per day for a maintenance dose thereafter, you should be able to manage the weight well. And there are professional boxers, Chris Aguilera is one, that he's a dietitian and just came out with a great book.
Yeah.
Hopefully you'll be able to talk to him while you're here.
Yep.
And he uses creatine as well. Now, they might taper off a little bit,
Yeah.
But there's no doubt that it improves performance, and as long as you don't have swings in weight, it should be fine in water weight.
With the UFC fighters and that sort of stuff, they get that 24 hours after the weigh-in to reload. And is there any benefit in putting it in there then?
So Chris might give you some insight. So one of the things they do is they use creatine during training. They might taper off a little bit toward the fight, but then once it's over, they use it as hyperhydration.
Yeah, right.
And build up to get the muscle loaded as well again. So, but the real interest in creatine, it's much more than just a performance supplement.
Yep.
There's so many medical uses now of creatine.
Yeah.
And one of these is there's these studies showing that if you have, mainly the studies are in animals because we have to do studies that actually cause concussion and brain injury.
Yeah.
And so we do these in animals, and the animals that are fed with creatine withstand brain trauma better, stroke better, heart failure better.
Yeah, wow, heart failure too.
Yeah, because when your heart lacks oxygen, it has to go to the more non-oxidative energy systems, and creatine provides that immediate source.
Yeah, exactly.
And so we're now looking at creatine as a way to reduce concussions and also the severity of things like spinal cord injury.
Yeah, okay.
In fact, our 2017 position stand on creatine was update. We basically concluded if you are a sport organization and do not allow athletes to take creatine, you are potentially putting yourself in liability just because of the potential reduction on spinal cord injury as well as brain trauma and concussion.
That's fascinating because, seriously, still, it was only a couple of years ago we had a potential person that wanted to invest into our company, and he explained to me that he sat down with his PE teacher, his son's PE teacher at the school, and they decided that creatine was a steroid and needs to be banned. So there's a weird public perception that creatine of all of them
and
is...
so you were asking about, well, how did it happen? Well, up till the early 90s or
but
so.
Was there any bad news, or was this just a...
Well, here's the history. So in 94, we'd come out with papers to show that it's working, right?
Yeah.
And up to that, the dogma in nutrition is just your normal diet. All you need is extra carbs. You don't need more protein, don't need any of these things because none of it works. That was kind of the idea. And so creatine was the first to really challenge with good scientific data to say, there is more than carbohydrate, and there may be benefits to athletes more than just maintaining a high carbohydrate diet and glycogen loading. And so when creatine came out, a lot of teams started using it.
Yeah.
I got a call from the University of Nebraska's dietitian, Dave Ellis,
Yeah.
right after we did our first study. He says, Rick, is there something to this? I said, well, here's what our data shows, and we're getting ready to do a replication. And they put him on creatine right away and won like 3 national championships right in a row in football, which is the top sport in college, athletes. And then a lot of other teams started using creatine and hearing the benefits. And, of course, the University of Memphis, we were doing it. We actually upset the University of Tennessee with Peyton Manning. Yeah. And they were like scratching, how in the world were you able to do it? And it's creatine, right? They put everybody on creatine next year, and then they won a national championship without Peyton Manning. So it kind of became very popular. And so the people who were against supplements, like, well, we can't let this go. There's got to be something wrong with it, right? So first it didn't work. Yeah. And it's like, well, maybe it works. So, well, it may not be safe. And so then all of a sudden, anybody that took creatine, the trainers and everybody were like, well, it had to be a problem. So somebody cramped. Yeah. It had to be the creatine, right? And in athletics, there's a lot of that type of thing. If you have 2 or 3 hamstring pulls, what is the strength coach doing? Are they doing some unusual training technique? It couldn't be our coaching. It has to be the strength staff. It has to be the diet. So we did studies at University of Memphis on safety just to try to test the hypotheses of whether there were more injuries, more cramping. And these are the hallmarks in the literature now on the safety of creatine. And we actually showed that if you took creatine, you had less cramping, you had less muscle injuries, you recovered faster after injury, and these are American football players. You tolerated heat stress better. And we now know mechanistically that all those things make a lot of sense. Absolutely. But it was because of all this misinformation. So what happened was in 94 or so, a wrestler supposedly was taking creatine and dehydrated and died.
Yeah, right.
So it was in USA Today. Wrestler death suspected to creatine use. Why? They had a theory that if you took creatine, it would suck all the water out of the muscle. It's completely opposite of what happens.
Yeah.
And this hit front page, and all of a sudden now anybody that cramps had to be the creatine. Anybody had, and so we actually wrote a paper in '98 that talked about, are there any legitimacy to any of these anecdotal claims about creatine? It was claimed to cause baldness. It was claimed to it was a steroid.
Yeah.
I mean, it was like anything you can think of. They were throwing at creatine, yet all the studies showed none of that was happening. In fact, it was the opposite.
Yeah, wow.
And now there's all these health benefits.
Yeah.
Things like even in third trimester pregnancy.
Yeah, wow.
The mother is actually needing more creatine in the diet.
Yep.
It actually starts pulling creatine from the mother to help with the formation of the child.
Yeah.
And what ends up happening is that if you feed creatine to moms, they are able to provide better creatine, so there's neuroprotective effects on the infant.
Wow.
And if they give birth and there's asphyxia, which is like blue baby where the cord wraps around the neck, very dangerous, can kill the child.
Yeah.
They withstand that a whole lot better.
Wow.
So even the third...
We talk about dementias and strokes and
Yes.
all that sort of stuff. So
Yeah, there's evidence on all those things.
Yeah.
So if you look at our ISSN position paper in 17, it goes through all these medical uses of creatine.
yeah.
Brain function, cognitive function, aging, preventing muscle mass loss and aging, for pregnancy, for all these things that are being studied now. And so initially it was down to, well, we had to say it didn't work. And
Yeah.
now all the studies
Now it
come
works
out.
so much it's got
It's
side
like,
effects.
this is really legitimate, folks. There's a nutrient that's
So-
very important.
When do you take it? So should an athlete, should it be taken in a pre-workout? Should it be taken pre-workout or post-workout after it's been depleted? Or
Yeah, you generally want to load,
Yeah.
and you typically will take 4 or 5 doses a day of about 1 teaspoon, which is about 5 grams.
Yeah.
If you have more muscle mass, you might need a little more. If you
Yeah.
have a little less muscle mass, a little less, but usually about 20 grams a day.
Yep.
And you do that for about 5 days. So that's the kind of the loading period. Some say you don't need to do that. You can take 1 teaspoon a day for a month. You'll get there.
Yeah.
But for performance, you want to increase that muscle mass as much, or that creatine availability, so you get the training effect.
Yep.
So we still load. And then once you've loaded and saturate the stores, you can about 1 to 2 teaspoons, depending on what muscle mass you have, can maintain that over time.
Yep.
And so in our large American football players that were up to 120 kilos, they would take up to 10 grams a day.
Okay.
And the smaller folks would take a little bit less. And so that's enough to maintain your level. If you stop taking creatine, it takes about 4 to 6 weeks to get back to baseline levels.
Yeah. Okay.
And so you could take short breaks, but now there's really no reason to stop taking. And in fact, the health benefits, we're telling everybody that 3 grams a day is probably what you need for just general health.
Does it matter at all when you take it then? Could it be are you better off with a high carb
Yeah.
meal, or are you better off around your training?
We know that if you ingest it with carbohydrate, it helps
Yeah.
because the insulin helps with absorption. There have been studies beforehand or after. Really doesn't get an acute effect of it. It's
Yeah.
more of whether you have the gas tank full.
Yep.
But there are some studies where if you take it after with your carbohydrate and your protein, like whey protein, you get this kind of milieu of nutrients that can enhance recovery.
Yeah, okay.
And so that's why we recommend athletes, once you've loaded, take with your carb and protein drink after a workout, and then usually you'll be able to maintain stores well.
And if we were to, be talking to the baby boomers and, looking at the prevention of that, would it matter when they would to use it?
Well, we generally recommend 3 grams a day just for general health.
Yep.
Okay, with no loading, just general. But we've even done studies in untrained versus trained.
Yeah.
And people aren't even training get benefit of creatine.
Yeah.
To some degree.
Yeah.
And there's certainly these other health benefits that we're finding out that creatine's involved in all type of metabolic functions and brain function, and basically creates in every cell, and is
Yeah.
an important mediator for energy metabolism. So if there's a limit in oxygen, limited ability to energy metabolism, and disease causes that, creatine seems to help.
So creatine monohydrate is the one that's been studied the most. Is
Yes.
there anything exciting in regards to the different forms of creatine?
99% of the studies have been on creatine monohydrate.
Yeah.
So that's what we base our recommendations on. We've actually done a lot of studies on whether you have liquid form or semi-solid form,
Yep.
or with carbohydrate protein, without carbohydrate protein. Does it affect uptake in different forms? Like you'll see companies come out with effervescent creatine.
Yeah.
You know, does the fizzing help with the absorption? Or,
Yeah.
or with bicarbonate and things to help buffer, you know, the buffered form of creatine. And we've looked at lots of types of different creatine. The bottom line is creatine monohydrate seems to still be by far the best.
What's the bioavailability?
It's like 99.9%. So that's the issue is, okay, you might get a little bit better stomach feeling if you take it with bicarbonate or whatever, but it doesn't really affect muscle. Really, it's the same.
It's the same absorption.
You have to make sure the same amount of creatine is being delivered, and some of the different forms actually have less percentage-wise. So creatine monohydrate's like 90% or so creatine, whereas effervescent or buffered form might be 65. If you equate the same amount of creatine, it will probably do about the same amount.
Yeah.
And so we've never found any advantage of the liquid versus the pills versus the chews versus
What about RTD? What if it's already pre-dissolved? Are they?
Well, our first studies were in a carbohydrate drink.
Yeah.
This was the old phosphagen HP that EAS made. It was kind of a hallmark. And then we did a study with carbohydrate protein, which was something called phosphagain.
Yeah.
And boy, that was the best stuff we've ever studied. I mean,
really?
if we want to build muscle mass in athletes, we give them carbohydrate protein.
Yeah.
There's nothing magical about the type of carb protein. It was basically the old metrics type of thing and then we were giving up to 8 grams per dose and giving 3 grams a day. So actually in our initial studies, we're doing up to 25 grams a day of creatine for 12, 15 weeks straight in athletes, and they were just getting massive. I mean, it was getting to the point where the position coach said, Doc, you got to stop this because they're getting too big. We're having to move running backs to the next position.
Is that right?
Because they're just putting too much muscle mass on.
Yeah, my goodness.
Yeah.
So you've been working on a book. You've been like pretty busy hiding in your hotel room trying to finish off this book, haven't you?
Yes.
So we're going to actually bring you to Australia and take you around and show everyone this book because it's pretty cool. So you want to tell us a little bit about that?
Yeah, so we did a book in 2009 on sport nutrition, exercise sport nutrition, and that was kind of the basis for the position stands that we did. We've then updated it. So this is the essentials of exercise and sport nutrition, science to practice.
Yeah, cool.
And so it talks about all the science in an easy to understand way, but then the bottom line is how do you implement it into a training program, what the training program should be, what the diet program, when to take what particular nutrients can actually optimize training adaptations and promote recovery and enhancement of training and health.
Yeah.
And so this book is kind of the essentials. It's about 460 pages or so.
Yeah.
And it's we're real excited about it because it's the latest information out there, and people are very excited to see it come out.
Because it's quite amazing. Some people still quote back from the year 2000 talking about what there is to be known about sport. And there's a lot of stuff that's happened since then.
A lot of stuff.
But including testing techniques and the ability for science to have got much better at even the old data redone should be coming out.
Well, I think what we're starting is re-examine things that didn't work. We kind of put on the shelf.
Yeah.
Because now with all the new metabolic capacity and genomics and metabolomics and things that can be done to really understand the mechanism, we're finding out that, maybe we just missed. We just assumed it didn't work, but there was some potential. And so I think that's enhanced. But if you look at exercise nutrition literature, every year there is just thousands and thousands of papers that are coming out showing that the role of exercise, nutrition, intertwine are involved to optimize health and well-being and performance. And so basing comments on something from 2000s is like the Stone Ages in sport nutrition.
Yeah, exactly. Yeah. And so Eric's talk yesterday, he mentioned the value in bro science as well. Sometimes the guys know when something's working for them. And you can get a scientific paper to prove it doesn't necessarily work. But Sometimes it's worth investigating with all the new techniques, huh?
Well, there's different levels of what you would do for supplementation. So the general health, mostly the diet and proper timing and nutrients are probably. But if you're an elite athlete, you don't always wait for the 0.05 effect, which is 95 times out of 100. It's not going to happen by chance. They may be willing to go with a 0.2 effect. If it works 80% of the time and I'm already at the elite world-class level, it may be worth trying as long as it's safe and it doesn't cause a problem and get me positive on a test.
Statistical significance for an athlete is a little bit different to
because
across the population, wouldn't it?
Even in our studies, when you compare the elite world-class to what we study, available sample sizes at universities or whatever, they're not the same type of individual, they're not the same type of athlete, and they're certainly not at the elite level, world-class level, unless you have the opportunity to work with some of those. But even then, you can't do a study with 50 world-class runners because they're not world-class if there's 50 of them, right?
Yeah, exactly,
Unless you go to Kenya and all the runners would be world-class if they're allowed to be in the same race, type of thing. But so there's these challenges, and so even with the science, you have to ask, what was the population?
Yeah.
What was the exercise consideration? What was the performance measure? Is it applicable to what's happening in the field and in the real world for athletes? And so in our book, we actually talk about how to evaluate the literature and know and ask these basic questions so that you can interpret the literature as you hear it and know whether, does this make sense or not?
And because like a meta-analysis or something like that, they might try to find consistent data that can be compared, maybe eliminating a lot of the really valuable stuff that an athlete could really benefit from.
Yeah, and I have some issues with that. So there's now kind of a big push to let's do these meta-analysis. And then meta-analysis combine a bunch of studies that have similar characteristics and try to get a strong conclusion based on lots of more people that were evaluated. And theoretically that makes sense. But the problem is unless every study is done exactly the same way, in the same population, under the same conditions, it's really hard to be able to interpret. So our approach is let's explain what the literature is comprehensively, and then after looking at it, let's come up with some conclusions based on what appears to be makes sense scientifically as well as the research results. And let people make an informed decision about what the data is so that they want to try it. So
and what's important to them.
Yeah, what an elite athlete may want to try may not be something that a bodybuilder may want to try. Bodybuilder may be more experimental than the elite athletes worried about drug tests and things like that. The person just starting a program wants some basic guidelines. They don't need to necessarily try a lot of things. Let's get them started on the basics. So actually my book goes from beginner to the elite athlete and gives you
and you're going to be given dosing and timing and all that sort of stuff and everything, and then referencing it so they all know where to go and find the full papers. Now, we know how dangerous abstracts can be. So your paper that you mentioned, all those side effects associated with creatine probably got quoted as the source of all the...
I was telling you the other days that, we're afraid we started that because there were so many things in the paper that I was asked to do a review for a sports science internet thing, and I thought I should at least address, is there any legitimacy to any of these? And Paul Greenhoff, who was a reviewer of it, it's like, do we really want to mention this? Because if we do, people are going to think there's actual science in it, but there wasn't. And so, I'm afraid that we bring it in the literature, then all of a sudden, it's been reported, and there's been suggestions. It's like, no, the point was there wasn't any literature to show it, and these things aren't valid, and the other research is
It's so important because there's a weird trend through social media. You've got, it used to be, I think it's 8 seconds or 10-second attention span or something like that. Well, it's down to about 2 seconds now because that's how long it takes. So you got to have like a statement with a reference. And people think it's got a reference, I've made a statement. So they could easily be saying, this study acknowledged these things and reference it here, and it's enough to keep it going.
And you have to look at the details, because if you just go by headlines, headlines can be very misleading. And, in social media, it's all about bait, clickbait.
Exactly.
And so they want something provocative. Creatine causes baldness. And then like, well, somebody mentioned this, and really there's never been any studies showing it, but the headline sticks with
Yeah.
people in their mind. And so that's a problem with nutrition and the social
Yeah.
media in general. So you have to be able to look at the science. You have to be able to read the paper and listen to people that actually are publishing and reviewing the literature. And that's why we did the ISSN. I mean, we started
Yeah.
it to help people understand what the science is and make informed decisions.
So anyone can join ISSN?
Yes, we have a Facebook page that it's wide open for. There's over 35,000 to follow that. And then we have the web page is sportsnutritionsociety.com.
Mm-hmm.
And you can go on there, you can join and follow and get access to all the great presentations and papers.
Like all the slides that are available from the show and everything.
And so we try to just present what we know, but then also be forward thinking. What are we all working on? What are we thinking? Where are we going to go?
Yeah.
And the traditional scientific conference is very conservative and thought that, well, we better not say what we really think because then somebody might think if we're wrong down the line, well, you guys said, well, we want to test the dogmas, to really think about, where are we going and what potential is out there to get people thinking and do the research.
Yeah, yeah.
And so that's kind of the fun part of coming to this conference. And then if you follow the Facebook page, we're always talking about studies, and the top people will chime in when they're asked to, when they can, and it's just a great environment for learning.
Yeah, it's excellent.
We were at our board meeting last night, and they said there was over 2 million downloads of our papers each year.
Wow.
Yeah.
Well, that's really impressive.
Yes.
So that's a big platform to work from, and it's really important that you actually get the chance to speak the truth in amongst all the other stuff.
And what's been fun since is that we kind of got out there with the first position stands and a lot of things like that. Now the other organizations are following suit, and they're looking a lot like our position stands and making similar conclusions. So now you have a body of different professional societies coming up with similar findings, so the people in the public can have confidence that this is what you should do to improve training and performance, and whether something really does work or doesn't work, or how to ask the right questions.
And what about trends? Like moving forward, I noticed in this talk there's a lot more talk about whole foods. Even the caffeine. They're comparing anhydrous caffeine to coffee and stuff, and showing all the benefits of the polyphenols. And we're talking a lot more about gut health and sleeping and removing all these handbrakes rather than pushing. What do you reckon the future trends?
I think those are some of the areas. I think in 1993 I did a paper, and it was what was the future of nutrition, sport nutrition.
Yep.
And I said it was amino acids.
Yep.
Here we are, right?
Yeah.
So now amino acids are all over the place. And I remember back in the day, the first paper we did on branched chain amino acids, the reviewer said, there is no way that any of this can actually work, and why are you even doing a study on it?
Yeah.
It's like, now we know, because we're doing the studies. So back then I thought it was amino acids. Amino acids are still huge.
Yeah.
But now we're moving into brain, neuroprotection, cognitive function. How can we enhance availability of nutrients and deliver them to the brain so that we can enhance memory and function as you age, as well as acute focus so that you can perform better.
Yeah.
If you're an athlete, it's the winning and losing occurs at the end of the game when you're tired, fatigued physically and mentally.
Yeah.
And so if you can optimize that as well as all the other nutritional and training adaptations, that might help. The role of gut and training.
Yeah.
We now know exercise affects gut permeability and all these things.
Yeah.
Can you provide pre and probiotics to try to enhance nutrient delivery, to further enhance the physiological effect? I think that's wide open. We're starting to do some of those type of studies. And, we're always going to be looking for things that can maximize the efficiency of energy metabolism and or factors that affect health. So what you're going to see in the future is the application of sport nutrition to health.
Yep.
Classic example is creatine with the health benefits and HMB with health benefits in elderly and other folks. May not be the greatest thing for athletes, but I tell you what, in sarcopenic individuals are aging and you're in the hospital, it helps recovery and maintain muscle mass and some other things. So you're going to see start application of sport nutrition to clinical medicine and nutrition, and I think it's just beginning. We're going to see a lot more things that we thought, the bro science, well, maybe why are these people taking these things? We may find some of them actually are reason, and they feel it and they want to do it. So not everything is like that, but there certainly are a few things.
I think the first time I saw you speak, you mentioned beetroots and Schisandra berries and all that sort of stuff, and that's why I thought, oh, here's my man talking about our stuff. And there's a lot of more data coming out about the role with herbs and then the microbiome.
Yes,
and
yes.
So postbiotic compounds and everything as well now.
Yes, absolutely. And I think that's another also trend to mention is we're going to see fruits and vegetable bioactives in their natural form being more used with nutritional supplementation because of all the other cofactors and things that are coming with the active nutrients that we don't yet even know how they're interacting. But if you give a natural form, you know, it seems to work better. So I think that's also a burgeoning area.
And the science has evolved a bit more now. We're moving a little bit, hopefully moving a little bit away from that medical model where it's all about bioavailability and systemic delivery of the actual compound. Because now we're seeing a lot of microbiome altering compounds and changing them and absorbing them later, or something where they miss the area under the curve and assume they're not bioavailable or something.
You know, one of the things we talk about in our book is that when you ask questions, the bottom line is, does it really affect the outcome?
Yeah.
So if I'm taking a supplement to increase muscle mass and strength and recovery, after 12 weeks of taking it, do I have evidence that you actually got stronger, bigger, faster, or whatever, or had a better health outcome? And there's a lot of stuff that acutely might do some things, but we don't know if it over time actually works. And so doing the studies to look at the overall effect, does it really cause an outcome? If it does, then to do the actual science, look at the mechanisms and things to further understand why it's doing that is kind of where we need to go, rather than just focus at, well, it works if you take the this particular compound when your blood levels go up, and it affects this biomarker and knockout mice or whatever is being studied. Yes, but does it really bottom line effect? And I'll give you an example. We did some studies on melatonin when I was at Baylor with Darren Willoughby and one of our grad students, and acutely it caused some hormonal adaptations. So of course it's going to promote this great adaptation. Bottom line is, after 8 or 12 weeks, didn't increase muscle mass. So you have to look at those outcomes. Does it improve health? Does it improve performance? And then understanding the mechanism.
Even a talk, I forgot the gentleman's name, but even a talk earlier where we were talking about the hormonal adaptations to strength training, and they showed some changes to androgens, but then they showed the reduction in the androgen receptor activity. So he's saying, so this goes up, that goes down, around the middle.
We balance out. And there's also, we did a really cool study with weight loss and genetics. Can you do genetic screening and identify fat-related genes and predict whether you do better on a high-carb or high-protein type diet or type of thing? And first 2 or 3 months, man, we're seeing some really great results. It looked like you can pretty much predict. But then after that, it kind of narrowed down to after 6 months, it really didn't matter. So there may be some of these things that work acutely, but then the body reacts and responds and it gets back to equilibrium. And then the bottom line is, does it make an impact overall?
Exactly.
So.
Oh, that's fascinating. And so lots of stuff's going to be in your book. You're going to come to Australia. We're going to take you around to see all of our mates and maybe give you a couple of days off, because you sound like you work pretty bloody hard. We got the book coming out. So when's the book out?
I just sent the last proofs today. And I understand in a couple weeks. So we have a website called essentialsofsportnutrition.com. So be looking for that. As soon as it hits, we'll announce it on our Facebook with our lab Facebook as well as the ISSNs. And we've got versions in Spanish in preparation. Colleagues from Colombia have been helping with that. Mara Marquez, who's actually here. And Diego Bonilla, Professor Bonilla, and Professor Jorge Petro. So they've got the Spanish version about ready to get hit, and then we have colleagues now asking from other countries to try to do the same thing.
Oh, brilliant.
So we're real excited about how this might have even more
I'll tell you, they'll interpret for Australian, they'll basically remove all the information out of it.
Well, it's interesting. Sometimes different countries, they get so focused on the legality and all this. You need to have these outside voices. We look at the literature, and here's what the review of the literature, and here's what the actual data shows. And when you look at the literature, you should always base your review and your guidelines on what the studies say.
So we've tried to do RTOs through ATP Science, a registered training organisation for the education points and everything for personal trainers and that sort of thing in Australia, and we're not allowed to actually talk to them about I'm not even sure if they're allowed to talk about macros, but definitely not allowed to talk about supplementation and that sort of stuff. So these sort of things you're not going to learn in Australia as part of your typical training. You're going to have to go and find it for yourself. And you've got to go and learn this stuff and have these books on hand and use this as a bit of a reference guide so you can go back to it, because it's going to have the most up-to-date information and all the references that you need to back yourself.
Comments, just something I've been quoted before to say is comments and regulation about nutrition, exercise, and dietary supplements must follow the science, available science. But realize the available science may be 5 to 10 years behind.
Yep.
And so the perfect example is, we finally did NIH studies on creatine after 15 years of it showing all these benefits. They started saying, maybe it can work in Parkinson's, maybe in other type of neurological diseases, and some appear to yes and some maybe not. But it took 15 years before the NIH says, it's worth funding a study, international study, to actually look at this.
Yeah. But then everything you've learned about creatine delivery to skeletal muscle, you can't relate that. We've got a blood-brain barrier in a way, and so it's all kind of going to start again to a certain degree, isn't it?
Yes, we're now trying to get the creatine levels in the brain. We're trying to find out, is creatine the best source or maybe one of the precursors to creatine. Yeah. So something we chatted about is acetoacetic acid, which is or guanidine acetic acid, which is a precursor to creatine that seems to go into the brain better. And some studies out of Poland by Ostrowicz and colleagues show that you get a much better brain change in creatine if you use GAA versus just creatine. Yeah. Both will work, but creatine you have to be very large doses over time to get there. So we may find other nutrients, but the physiology, if you increase creatine content, it helps brain function, memory, all these type of benefits. So, the world is wide open to get into the brain. Yeah,
that's exciting times. So we've got to definitely work more on that. Well, is there anything else you wanted to talk about, Rich? Anything else we wanted important to tell the people?
No, just based your decisions about dietary supplements, nutrition, exercise on available science. Yeah. Look to ISSN and other great organizations to give you a clue about what would work. Yep. And if you do that, you're going to stay in the right.
Yeah, and in the most up-to-date information. Yes. And don't keep referencing the same old papers.
Yeah, because the field is changing so often. I mean, even from the time we did our sport nutrition reviews, we try to do one every 5 or 6 years or so. The amount of data coming out on topics is just amazing. Yeah. In fact, my last class I taught this spring, I used my old book, but I then gave the students access to the new one I was working on. And the question was, how much has changed over the last 8 or 10 years? Yeah. And some things that look promising haven't been picked up, that are still promising, need to be studied. Some things there have just been a plethora of information come out on, and we now thought we knew that we now have much more clarity on whether something does or doesn't work.
Have you changed your position on anything in particular? Was there something in the last book that you said doesn't work, or
great question,
or does, and then this time it just doesn't?
Oh, great question. I probably, we have in the book, and the ISSN position stand also does this. It rates the categories as something that seems to work. It's good evidence behind. Seems that some things that have good theoretical knowledge and maybe a little bit of data supporting, and things that don't seem to work. There's some things that we thought might have been helpful that probably aren't. Yep. And there's a few category changes. So, but there's a few of the shifts. So if you compare the categorization, there's a few things that went from not enough data that now maybe. Yeah. There's a few things that went from maybe to now we know that there's just not any evidence to it. So there's been some subtle shifting, and we're always looking at the literature to try to make the best recommendation for people.
Yeah, that's excellent. Yeah. No, things keep changing. It's an exciting industry to be in. It's good fun.
It is. Yeah.
It relates to absolutely everyone, and not just all the way from the elite athletes, but what we learn from elite athletes is amazing that we can use in the everyday athlete, but also protecting the elderly and the more vulnerable people. Yeah. So it's probably because athletes are harder to kill, cheaper than replace.
Well, they're testing the bounds of physiological limits, right? So we can try things, and that might give us a clue what the limits are. It might give us a clue what the delimitations are if you have disease. And so that's what you're seeing. You're seeing the creatine, the post-exercise or protein being given to hospital patients, and you're giving different types of nutrients to special conditions to try to help them manage the disease a little bit better. It won't cure the disease, but it help manage it a little bit better.
See, I'm really loving this whole trend of the whole food stuff. Even you mentioned earlier that predicted amino acids to be the trend, and now I'm starting to see a lot more talking about the different peptides or the less processed forms of the wheys and the bolus sort of proteins having a more of a significant effect. Is that something you've noticed?
Yeah, absolutely. I mean, we look at individual amino acids, but then it's all these polypeptides that seem to have also triggering mechanisms as well. So I think that we're going to find certain forms of the amino acids, certain fragments and things that may be found in whole foods to a greater degree, might be the kind of keys to unlock certain pathways. I think it's wide open. I think protein's still...
book, I mean, your book's going to be only published data, huh? There's not going to be the unpublished confidential data that's being held back from... for example, there's a lot of data on collagen that hasn't yet been published. You wouldn't have had any of that in the book at all, would you?
No, we might tell us what we might be working on a little bit to get some clues. But there's a whole bunch of data that's sitting there waiting for patents and stuff. And so actually, when I do literature review, it's not just what's in PubMed and those things. I actually look at the patents to try to figure out ideas.
That's good. So when you do literature review, this is really interesting because Australia would be like PubMed. Typically, would just be in PubMed. And if it's not in PubMed, it doesn't exist.
Right.
So you're saying there's a lot more data hidden up in
I think if you're trying to be on the novel front edge, you need to not only look at what's been published in the traditional peer-reviewed literature, but you look at patents because people are trying new things, and usually every patent has a little bit of pilot data in it to substantiate the validity of the patent. And that gives you clues about what might work. And so we've actually used some of that. And then Anthony Ma is a great person that he would have access to abstracts that are being presented all over the world with different. And so sometimes those novel abstracts might give you an idea that, hey, maybe there's something to this. So I think a good scientist is looking at the novelty. What's coming out and what potentially, and we've been very fortunate over the years to do a lot of the beginning research on lots of nutrients, from creatine, some of the initial HMB in athletes, to CLA in humans, and you look at, well, how could we have been kind of on the right track with so many of these? It's because we were looking at what was coming out, and some things didn't pan out. We did a lot of studies that don't work. But on the other hand, there have been a few that have hit pretty good, and the reason is because we were like the first to the market or to do the studies. So
it's important to be part of something like ISSN to keep keep your finger on the pulse, and then have that network of people that are sharing information before, well before it gets into the public domain.
And the other thing we do is we look at what's coming out in the basic animal research, because that also gives you clues about what potentially might work in a human. Now, animals are different than humans, and they don't always relate, but, we did this first CLA study, conjugated linoleic acid study, in humans for training and body composition and bone health. Well, the initial stuff out of the University of Wisconsin, it had patents and had a number of nice papers in animals showing all types of benefits of CLA. It had to be done in humans. Well, we were the first ones to do that with some of our colleagues that worked with Anthony and others at EAS at the time. And so HMB in animals, and Iowa State folks did some studies with it, and we were the first one to actually try to do it in trained individuals. It seems to work better in untrained than trained, but you have to be looking at those initial studies to give you clues about what might work in a trained condition.
And so there's no good news or bad news, just news. It's just a matter of gathering data, and even a bad result in a study might highlight a bad testing technique that we still need to publish and share so we can improve science.
Absolutely.
But that's the stuff that people often quote and share and say, this is why it's all rubbish.
And you have to be careful when you see a study that shows no effect. Don't just necessarily completely dismiss it, because if they're not using the right techniques, the methodology and application, you might miss a lot of stuff. And some things, we didn't think did as much. I mean, protein, amino acids, perfect. There's no need to have any amino acids. We now know that we have better methods of doing tracer studies. And, hey, there's some roles to this. So I think you have to kind of look at the initial studies as a beginning, and then what you want to look for is a pattern of studies showing an effect to make a conclusion. But if you're not looking at that basic research, you're not looking at the patents.
Or piecing it all together. I mean, so it takes lots and lots of bits of data to create a conclusion, which is why your books are important. Because if you look at muscle hypertrophy, we might say, oh, it showed no effect on muscle diameter, but then you might have satellite cells, ribosomes, sarcomeres.
Absolutely.
There's some other data that other studies are showing it has an effect on. So you go, oh, so this is how it's working.
Yeah. And one of the things we've enjoyed over the years is working with some of the research and development officers for some of the companies who are more venture capitalistic in mind, in that let's try this, let's do a study, and a lot of things don't pan out. But on the other hand, if you have something that kind of shows some effect, and you do another study, and then other people start replicating, and you start seeing you're going to build, you have something to build off of. But that's the nature of science. No one study means it all. It's a matter of doing lots of studies over time.
Yeah. No, it's amazing. Oh, it's going to be fun. Well, we better wrap it up now, and then we'll do a heap more of these, I reckon. We're just going to bug the hell out of you. No, it's good commentary. I mean, you're one of the experts in the industry, but it's the history and the overview of all. You put everything in perspective for us, and I think the listeners will really appreciate it.
We've come a long way from the day when I was training that all you had is egg protein.
Yeah.
And you eat a lot of steak.
Yeah.
And that was about it.
I still like steak and eggs, though. That's all right.
Yeah, Joe.
Well, thanks, Rich, and someone will sign this off when one of the adults come in. How do the people end these shows? I normally have an adult in here doing the interview, but yeah.
Very good.
Any last words?
No, good day.
Yeah, that's it. Good work. All right, cool.